Anyway, we'll go on from here. So how do we go about then? How do we go about undoing times by a matrix? So we had this idea of the inverse of A, of matrix A, times A itself gives us this identity matrix. And the identity matrix for a 2 by 2 is this. All right. So if I can multiply the inverse of A by A, I get this identity matrix. If I multiply the identity matrix by some other matrix, then what I'm actually going to get is just left with that matrix. So in effect, if I were to do the inverse of A times X, then this here is going to be equal to the identity matrix, and then this is just going to be X. And on the other side of the equation, sorry, that's yeah, that's right. So on the other side of the equation, we've got B. Because we multiplied this side by the inverse of A, we have to multiply this side by the inverse of A. So now I have this expression that says X is equal to the inverse of A times B. So in effect, multiplying something by the inverse is the same as dividing it by that in algebra. So they're the same operations. Does that make sense to everybody? I'll go through that again in a second when we get on to exercise 5, because this is how we're going to use matrices to solve problems. Okay, so if we keep going through this, matrix A. So if A is equal to, and let me go back to the question. A is equal to 7543 A is equal to 7, 5, 4 and 3. That's not very neat, Mr. Pate. Then the inverse of A, is equal to 1 over the determinant of A times the adjugate of A, or the adjoint. So, we have this process. We know that the determinant is AD minus BC, and we know that the adjoint is swap these two over and make these two negative. And we can do all that by hand, but luckily for you, you don't have to. We can go to the calculator, because I can make it. All right, so we've got matrix. Oh, I need one of those. So matrix A is 7, 5, 4 and 3, and I'm going to store that in A. Okay, so I want the inverse of A, so I can go righto A to the power of -1, and there's my inverse. So A -1 is equal to 3, -5, 4, 7. Okay. So I'll do it again. So you put that in there, and then I press Control and store. Right? So see the STO? Right? And then you can choose any letter you like. And then to get it back again, you press the var button and you get a list come up here of all the and then to the power, yep, so yeah, to the power of the little hat, -1. All right. Yeah. So see here, see the button that's showing up red now. So that's to the power of, and then you just go -1. So 2 to the -1 is a half. All right. So where are we up to? Okay. So what we're trying to do, remember, here is actually, this is actually our equation. We're trying to find out what x is. We know what A is and we know what B is. They're both matrices. And we're trying to find out what x is. So what do I have to multiply A by to get B? That's basically what we're trying to find out. So we found out what the inverse of A is. Let's write these things down again. So we know that A is 7, 5, 4, and 3. And we know that the inverse of A is 3, -5, -4, and 7. Okay. Now it's a bit of a coincidence that these numbers are so similar. Okay. And that will be a factor of what the determinant is. I imagine that the determinant is probably 1. 21 minus 20. Yeah, so it's 1. So that's why these are so similar. But that's a coincidence. All right. So from here, so x is equal to the inverse of A times B. So the inverse of A is 3, -5, -4, and 7 times B, and B is a matrix. If you look back at the question, that is 6, -3, 3, and 7. Okay, and guess what time it is again? It's calculator time. So on your calculator, you can work that out. Let's have a go. So we've already got the inverse of A. Here it is. I'm going to times that by B, which is 6, -3, 3, and 7. So we've got 3, -44, -3, and 61. So that is x. So if I was to multiply A by x, I would actually get B. So the point of finding the determinant is one step in finding the inverse of a 2 by 2 matrix. Finding the inverse of a 2 by 2 matrix helps us do this matrix arithmetic. All right, I'm just going to